Video to help you with the worksheet over distances. I'm going to do a few, then I'll send around some other stuff that'll help you. But try to do as many as you can. Make sure you're reviewing for your exam. Your binders are due this week, so make sure that you're getting those in order. Do a semester exam review. This first one, got to know that this line right here is a horizontal line, or that. So we just go to where y is 4, 1, 2, 3, 4, up 4, and it's going to be a horizontal line that goes right across like that. These are pretty easy. Then we graph this point, left 2, down 1, and to find this distance, remember distance always has to be perpendicular from the point to the line, so it's just going to go right to there. That's where it makes a right angle, and all we do is count 1, 2, 3, 4, 5. So this distance is 5. If it's horizontal or vertical, not too difficult. Second one, got to know that this is a vertical line. So we go to where x is 3, 1, 2, 3. We're going to draw in a vertical line, just a little bit there. And then graph this point 0, 2, that's right there. And then all we got to do, that perpendicular is going to be right there. And we just got to count 1, 2, 3. So this distance is 3. Again, if the vertical, horizontal, you graph them, then you count, not too hard. The other one's a little more difficult. This next one, they give us the this is in a horizontal or vertical line. So to graph it, remember we start at the y-intercept, which is 2, so we go up 2, put a dot. This slope tells us to go up 2 and to the right 1. So we go up 2 to the right 1, up 2 to the right 1, up 2 to the right 1, or we could go down 2 to the left 1, down 2 to the left 1, down 2 to the left 1. It's going to look something like that. And then we graph this point. 1, 2, 3, 4, 5, 6, 7 to the right and up 1. So we're trying to find the distance from this point to this line. We find the perpendicular to get us to that line, so we know exactly where we're going to hit. We find the slope of the perpendicular that's going to go to it. So the perpendicular slope, well, it's just the opposite reciprocal of this original slope. So if that slope was 2 over 1, we flip it over and it becomes 1 over 2. And the opposite, this one was a positive, so this one's going to be negative. And it doesn't matter if we put the negative on the top number or the bottom number, but only put it on one of them. So I'm going to put it on the top. So the slope's -1/2. Well, that tells us to go down 1 and to the right 2, down 1 to the right 2, but we're not getting closer to the line. So instead we need to go up 1 to the left 2, up 1 to the left 2, up 1 to the left 2. And this time we get lucky and we hit right at that point. And then all we're going to do to find that distance is we're going to use this point and the distance formula. Well, the one point is 7, 1. We know that. They gave that to us. And then we got to find the coordinates of this point right here. So we go to the right 1 and up 1, 2, 3, 4. So it's 1, 4. Then the distance formula. Remember the distance formula is x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. This is an x, that's a y, that's an x, that's a y. And we just plug those in. So I got 7 minus 1 squared plus, and then our y's, I'm going to turn them around, 4 minus 1 squared And grab your calculator, and remember you can punch all this into your calculator just like that. And you should come up with 45, then we still got to take the square root of that, ignore that. And the square root of 45 is about 6.7. So that's our distance. And then we can look at it to make sure, just counting 1, 2, 3, 4, 5, 6. We can't really count, but we can get an estimate. We're going across about 6 blocks. So 6.7 would make sense. All right, jump to number 5. I graph it. The line, this is a 1 here, so that slope's going to be 1 over 1. I go up 4, 1, 2, 3, 4, put a dot, that's my y-intercept. Then up 1 to the right 1, up 1 to the right 1, up 1 to the right 1, down 1 to the left 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 1. So our line's going to look something like that. The point that we're looking at is 2, 1, 2, 1. It's right there. To see where we hit at, the slope of the perpendicular would be the opposite reciprocal of this one. So it'd be, you flip it over and change the sign, so it's just going to be negative 1 over 1. Ignore that. It's a negative 1 over 1. Tells us to go down 1 to the right 1. Again, we're not getting closer to it, so we want to go up 1 to the left 1, up 1 to the left 1, up 1 to the left 1. Well, we don't hit exactly a point. And some of you could probably guess that looks like it's probably about halfway on both of them. And that's fine, but we want to be exact. So what we can do is either we can use systems of equations, or we can just use that formula. And that's what I'm going to use. I'm going to show you using the formula here. The formula, again, looks something like this. You got the absolute value, and it's a times x1 plus, ignore that, b times y1 plus c over the square root of a squared plus b squared. Now the bad thing with this is we got to take this original line up here and we got to change it into where zero's on one side and everything else is on the other side. So we got y equals 1x plus 4. We subtract 1x on both sides. We end up with negative 1x plus, and I'm going to put 1y, same thing, equals 4. Then we got to move the 4 to the other side, so we're going to subtract 4, ignore that. Subtract 4 on both sides, and I'm going to rewrite it over here. It's negative 1x plus 1y minus 4 equals 0. We want it in that form where everything's on the left and zero's on the right. This is our A, that number that's with the x. This is our B, that number that's with the y right there. And this is our C. Make sure you don't forget the sign there. Then our x1 and our y1 is right here. That's x1 and that's y1. And we just plug them all in. So A is negative 1, x1 is 2, plus B is 1, y1 is 1, and C is negative 4. All that over the square root of A squared. A was negative 1, so negative 1 squared, plus B was 1, so 1 squared. Plug all of this into your calculator, and when you plug it all in, when I plugged it all in, I came up with, I still got the absolute value, came up with negative 5. On the bottom, plug all of this into your calculator, and I ended up with the square root of 2. Ignore that. And absolute value of negative 5 is just 5. The square root of 2 is about 1.4. And then divide that, 5 divided by 1.4 is about 3.6. So our distance there is about 3.6. And we look back over here and count 1, 2, we go across about 3 blocks. So 3.6, that would probably make sense. So different ways to do it, using this formula, finding the point and using the distance formula, or you could do systems of equations. I didn't do any systems of equations here, but that's something, another way that you could do it if you don't mind systems of equations.